Hello everyone. So I work at CSIRO's Data61 and in a team called Confidential Computing, where our focus is on privacy preservation. And so today I'm going to look a little bit more lower level at one of a linkage methodology and technology that can potentially help. So we have a technology program about privacy at Data61, and I'll just briefly go over some of those which many of you will have heard of or been involved in. So the first one, very similar to that, Neo4j, graph analytics that we just saw. Phil, we have a project called Investigative Analytics announced in last year's budget, where we're doing graph-based machine learning, including entity resolution. So taking transaction and unit level data in a graph format and being able to process that. Another one that we have, how do I go through these? That would be a good thing to start with, is Pretory, which offers a perturbed, like confidentialization on the fly to unit record data. It's on the, in the case where you want to allow researchers to carry out queries where you might be asking for aggregate information, like count the number of people in this category. Like an SQL clause, we've got various where clauses. Pretory is an API that you put between your data and the researcher, and it will, using ABS methodology, perturb it in a way where you can guarantee the individual records won't get leaked. And we're working on enhancing that to be differentially private. The second one there is Sender, or sensitive access to data, which is a tool, also one of the PFOD projects, where it has an audit trail so that users who want to access sensitive data have a workflow they go through where as much can be automated is, and whatever has to be validated with a human user is as well. And data will be extracted in a format and sent to a secure enclave, for example, for processing. N1 Analytics is another in that family, and this is a technology mostly taking advantage of homomorphic encryption, but essentially it's trying to answer this question: can we get insight from data that's federated without having to bring it together, without having to share it necessarily? So can two organizations who want to do some sort of joint analysis, whether that's a simple SQL query again, but the data is now federated, or maybe it's learning a machine learning model, N1 Analytics takes this partially homomorphic encryption technology to answer that question. Another one that came up earlier in the discussion that's a little, I think part of the research side of Data61 is on risk re-identification assessment, and we have a tool and I believe a guideline published recently. There's been a few guidelines published that organizations are saying. So we also have a PDF, I believe, on the website that talks about assessments to make before releasing data, and so whether or not you can be confident that it's not reversible. Okay, but what I want to talk about is privacy-preserving linkage. So what if we don't want to or can't trust some intermediate third party? So at the moment, we're kind of mutually trusting someone with personally identifiable information, but that's not always going to be possible. And even if it is possible, if you don't have to disclose personally identifiable information to carry out your linkage, wouldn't that be better? So if we can think of personally identifiable information as a little bit of a liability. Like, I'm trying to think of a good analogy, and I came up with asbestos. Like, if it's stable and you use just for purpose, it's actually relatively safe, but if you disturb it or it gets used in the wrong way, it's really dangerous. And it's far better if you just don't have it. So if you can mitigate the risk by not collecting it in the first place. So the piece that I'm particularly going to focus on, if this is a view, and this is a very restricted view of probably some of the processes that are carried out and the case studies covered today, where we go through ethics, we go through this privacy impact assessment, and we have controls in place before a linkage is carried out. All I'm thinking about and focusing on from here on is the technology piece, the actual extraction of data. Sorry, I realize you can't read that. The extraction of data and the linking of data. So what is the problem? We want to link records, personally identifiable information like names, date of birth, email address, phone number, and we have two constraints in place. We can't share PII between each other or to a third party because we don't want to trust anybody if possible, and we have to keep in mind that personally identifiable information in the real world is messy and it will have errors, small errors, and so we want to use some sort of fuzzy matching or a probabilistic linkage. Okay, so a way to do that is hashing in the sense if we don't care about having fuzzy matching, you could just hash some of those variables and compare them, right? But that won't give us the ability to compare things in a probabilistic way. And in order to do that, we need to take into account some method that will preserve similarity of hashes. So unlike a normal hash where Thomas Clark and Tom Clark are completely different hashed outputs, we need a similarity score that preserves that. And the way we do that is using something called a cryptographic long-term key. Now, this is something that has been published by Rainer Schnell out of the German Linkage Institute, and it's been looked at here in Australia from CSIRO, from ANU, from Curtin University. And the technical explanation I'll mostly gloss over, but I wanted to try to give a bit of a feel for it. Essentially, it's this really cool data structure called a Bloom filter, where neighboring letters, so pairs of letters in different features, such as your name and address, are hashed. And the Bloom filter itself becomes this anonymous linking code that gets uploaded to a linkage authority, but it's done in such a way where you can't reverse out. And when you compare two of these codes, you get a probabilistic score of how many of those bigrams or the pairs of letters were in common in the original features. So the way this works overall would be kind of like a federated computation where some processing has to happen on the client side. So two organizations, A and B here, would share a secret which they're not going to share with a linking authority. They carry out a process to create these cryptographic long-term keys. They each upload them to I phrased it semi-trusted, so we have to trust them a little bit. We're giving them access to all these cryptographic long-term keys. They do the rather expensive comparison job of comparing all the entities from A to all the entities in B, and outputting a linkage table or perhaps the raw scores, depending on the privacy constraints and what you're after. And then that result would get used in a ETL process or something later to actually extract the features which you're wanting to use for the actual research. But as was touched on earlier, as a separate part of the problem. So within the confidential computing team, we've developed a prototype of this. We've open sourced a couple of libraries, and we've started working to validate the accuracy as well as the scalability and real-world applicability of this. The first one is the tool that runs on the client side. So at the moment, this is a command line tool written in Python, running on Windows, Linux, Mac, and it will hash the data and take those secrets and then interact with a service, a REST API that we wrote. You can find that on GitHub if you're interested in playing. And on the linkage side, it's a much more difficult engineering problem. Because of the n-squared nature of comparing all of the clicks on one side to all of the clicks on the other, we really had to think hard about how to make this scale to population of states or country sizes. So we believe we're well on the path to doing that. We've got a solution where the library itself is open source, and that's on GitHub as well. These are probably a few buzzwords, like we deploy to Kubernetes, it's horizontally scalable, and then some numbers. When we put it on Amazon, we get around about 1 billion of those comparisons per second. And we've done tests with 1 million to 35 million records in this privacy-preserving way. I don't have great validation numbers though, and I'd like some help there. So we've started doing a case study with some departments within New South Wales. So working with the Data Analytics Centre, the Department of Finance, Treasury, and Department of Justice. And they've just started this week iterating through the schema, which is kind of the knobs you get to tweak in order to get a good matching. And so I'm excited that next week or so I'll be able to say, well, and it works really well. Of course, we've done tests on generated data and open data, and we can achieve 99% precision and recall and things like that. So we're quite confident that it will be validated, but a future direction for us is to actually concretely have that. Yeah, I think I'll close there. Thanks.